Hey everyone, let's talk about an interesting geometry problem. We are asked to find the shaded area in a figure like this. We are given a couple bits of information that ABCD is a square with side lengths of 10 units and the triangle AND is equilateral. So in general, the strategy for finding shaded areas is to find the separate areas and then subtract. So that's what we'll do here. We're going to find the area of the square and then the area of the triangle and subtract the area of that triangle. The area of square ABCD will be the side squared. So 10 times 10, which gives us 100 square units. Now what about the triangle? We're told that triangle AND is equilateral. Well, that tells us a couple things. One thing, we know that all these angles are 60 degrees, they're all congruent, and we know that the side lengths are all 10 units. We also know that the area formula for a triangle is 1/2 base times height. Well, we know the base of triangle AND is 10. So how do we find the height of this triangle? We could drop a perpendicular bisector from point N, from that vertex N to the base. And that does a couple things. It gives us a right angle here. It bisects segment AD, so this segment here is 5 units, and it also bisects this angle up here, which, as we know, angle N overall is a 60-degree angle, so that makes that 30 degrees right there. Now, when we have a 30, 60, 90 triangle, we know that the side length ratios are x for the short leg, 2x for the hypotenuse, and x root 3 for the long leg. So that means that the short leg here being 5 will mean that this height, the long leg, is 5 root 3. And if you have any questions about that, stick around to the end of the video and I will show you how to work that out with the Pythagorean theorem. But now, having that height, we can calculate the area of the triangle. So the area of triangle AND equals 1/2 the base, which remember the overall base is 10, times the height, which we just figured out is 5 root 3. So that gives us 50 root 3 over 2, which simplifies to 25 root 3 square units. So we've got our area of our overall square and the area of the triangle we want to deduct. So the shaded area equals 100 minus 25 root 3 square units. And for the last bit of the video, as promised, I'll show you how to calculate these side length ratios. Recall that when we started the problem, we were told that triangle AND is equilateral. And then we dropped a perpendicular bisector because we need that to get the height of a triangle. And that also gave us a 30, 60, 90 triangle. Because we knew we started with a side length of 10, that gave us this segment here being 5. Now, this side of the 30, 60, 90, this side over here is the hypotenuse, and it is 10 units. So we have two sides of a right triangle, and so we can use our old friend, the Pythagorean theorem, to figure out this. Now, we already know that because it was given, but I will show you how to calculate it. So using a squared plus b squared equals c squared, and remember c is always the hypotenuse. We'll call this side A, where we have 5, and this side B, and let's pretend that's the one we don't know yet. So we have 5 squared plus b squared equals 10 squared. So that is 25 plus b squared equals 100. Subtract 25 from both sides. and we get b squared equals 75. We take the square root of both sides there. We get b equals, well, actually I can rewrite square root of 75 as the square root of 25 times 3. And since 25 is a perfect square, that can be factored out, and I get b equals 5 times the square root of 3, which is what we have up there. And so that is how to take an equilateral triangle and split it with a perpendicular bisector, giving you that 30, 60, 90. And then you can either use these ratios, which you might want to memorize, and I highly recommend that, or you can always go to your great friend in geometry, the Pythagorean theorem.